In this lecture, it is a second lecture on ARMA random processes, auto-regressive moving average process. Here, we are going to discuss a small problem based on the moving average process whose characteristics like mean, variance, and autocorrelation function was discussed in detail in my previous lecture. Right, let us now take the problem. Find the mean find the mean autocorrelation function find the mean autocorrelation function and variance for a moving average process of order 1, a moving average process of order 2, and a moving average process of order 3. Okay, so order 1, 2, and 3, assuming that assuming that a steady state has been reached. A steady state has been reached. So these things we have to keep in mind. Steady state is reached, and my order is 1, 2, 3. Okay, and we are going to consider the case k is greater than q for the model discussed in the previous lecture. So, but anyway, we will rewrite the model. For the model, x of n equal to summation k equals 0 to q bk w of n minus k for all n greater than equal to 0, where my w of n is a white stationary process. It is a white stationary process with a zero mean, with a zero mean in the sense my E of W of n equal to 0, and a variance sigma squared equal to E of W squared n, W of n whole squared, so E of W squared n for all n greater than or equal to 0. This is the same thing that we described in the theoretical approach. So we are now going to apply the theoretical approach where the order is taken to be 1, 2, and 3. My x of n equation is clearly stated as k equals 0 to q bk w of n minus k, and from the given details I can very clearly see that my mean is 0, which is going to make things a little easy for me. So now for the given moving average process, let us now generally consider, okay, ma of q. Then from the data I have my E of W of n equal to 0. So mean equal to 0 for all n greater than or equal to 0. So now let me start calculating ma of 1. So this in terms is nothing but my q is equal to 1. So my x of n is going to be summation k equal to 0 to q bk w of n minus k. Here q equal to 1. So for an moving average of order 1, my x of n will now be equal to summation k equal to 0 to 1. I will have bk w of n minus k. So this when k is 0 is b naught w of n plus I will have b1 w of n minus 1. All this holds good for n greater than or equal to 0. Next, what happens to my autocorrelation function? I have to take Rxx of k plus m comma k. This is nothing but Rxx of m. It would be more appropriate to write k comma k plus m, or just I am taking the difference k plus m minus k in the time interval. This is bigger, so more appropriate to write as k comma k plus m, which gives me autocorrelation of m. So this is nothing but sigma squared summation r runs from 0 to q minus m br into br plus m for my m lying between 0 to q. So this gives me my Rxx of 0 to b. I put m equal to 0. I will have sigma squared summation r equal to 0. Q is 1. So q minus m will become 1 minus 0. br br plus m will now become r plus 0. So this is nothing but sigma squared summation r equal to 0 to 1 b r squared, and this leads to the result sigma squared into b naught squared plus my b1 squared. This is Rxx of 0. Next I need to find Rxx of 1. So Rxx of 1 will be sigma squared. I will have sigma r equal to 0 to 1 minus of 1. So and then I'll have br into b r plus 1. So this is sigma squared b into b naught into I will have b1. I will have b naught into b0 plus 1, that is b1. So in general my Rxx of k will be equal to 0 when k is greater than 1, strictly greater than 1. Okay, so the steady state variance, therefore the steady state variance sigma x squared of k will be nothing but Rxx of 0. In other words, you would have learnt it as average power in certain cases in earlier studies. So this is possible since mean is 0. Okay. Also, autocorrelation function is an even function. So Rxx of minus k is nothing but Rxx of k. Next, first case is over. We are moving into the second case where we have to find moving average process of order 2. So here my q equal to 2, and so my x of n in this case is summation k equal to 0 to 2. I will have bk w of n minus k. Right. Now moving on to the solution. Here my x of n will turn out to be b naught w of n plus b1 w of n minus 1 plus b2 w of n minus 2. All this is true for n greater than equal to 0. Hence, my Rxx of m will be equal to sigma squared summation r equal to 0 to q minus m br b r plus m for 0 less than equal to m less than equal to 2. So my Rxx of 0 in this case, so m will be 0. I will have sigma squared summation r equal to 0 to 2 minus 0. I will have b naught So rather here I have m is 0. So I will have br plus 0. So this would be simply br squared. This gives me sigma squared into b naught squared plus b1 squared plus b2 squared. So this is rxx of 0. So my rxx of 1 in this case would be sigma squared summation r equal to 0 to 2 minus 1. I will have br into br plus 1. This will give me the result as sigma squared. I will have b naught b1 plus I will have b1 b2. So this is rxx of 1. Next, we need to find rxx of 2. My rxx of 2 is simply going to be sigma squared br plus 2 for r equal to 0. Because 2 minus 2 becomes 0, in the summation the top value is 0, the base value is 0. So you will only land up with sigma squared b naught b2, a single term. Now my rxx of k in general will be 0 for all k greater than 2, and this is possible because mean is 0. Also, my autocorrelation function is an even function, so my rxx of k will also be equal to rxx of minus k, and hence the steady state variance and hence the steady state variance sigma x squared of k will be equal to my rxx of 0, which is sigma squared into b naught squared plus b1 squared plus b2 squared. Right. Now we go on to find moving average of order 3. So in this case, my q is going to be equal to 3. So what happens to my x of n? My x of n will be b naught, w of n, b1, w of n minus 1, b2, w of n minus 2, plus b3, I will have w of n minus 3. So 4 terms will be there and the condition n greater than or equal to 0. So in this case, my rxx of n will be sigma squared summation r equal to 0 to q minus m. So it will be 3 minus m. So if I take an m here, I should make this also m into br into br plus m, because we don't want to confuse with this n and this term inside the autocorrelation function. So with this, we have rxx of 0, that is I put m equal to 0, is sigma squared r runs from 0 to 3 br plus 3. So this value is now sigma squared. R is 0, I will have b naught b3. R is 1, I will have b1 b4. R is 2, I will have b2 b5. Is it so? Please look at this. Is this what you will be getting? This will not be the term that you will be landing up with. What you will be landing up with is, you should have noticed by this time, after having done so many cases, I am taking rxx of 0. So here my m value coming down should not be 3 but should be 0, and so I will just land with sigma squared br squared, which is nothing but b naught squared b1 squared plus b2 squared plus b3 squared. Okay, so this is what we will be having. Next, I need to find rxx of 1. When I have to find Rxx of 1, I will have sigma square r equal to 0. I have to run to 3 minus 1, that is 2, into br into br plus 1, because m equal to 1. Okay, so this will give me, I will have sigma square, and then I will have b naught b1 plus I will have b1 b2 plus I will have b2 b3. Next, I have to move into Rxx of 2. When I go for Rxx of 2, what will be the condition available here? My Rxx of 2 would be sigma square summation r equal to 0 to 3 minus 2, value will just be 1. I will have br into br plus 2, and this is going to give me two terms, sigma square. I will have b naught b2 plus I will have b1 b3. Next, I need to find my Rxx of 3. This is going to be just one term, sigma squared br into br plus 3, which is nothing but sigma squared b naught b3, because this I have to find at the point r is 0. In general, let us go for an Rxx of k, that is autocorrelation function with tau equal to k. We know that this value is 0 for all k greater than 3. Moreover, our autocorrelation function is an even function, so Rxx of k is equal to Rxx of minus k. Hence, the steady state variance, hence the steady state variance for the given problem is sigma x squared of k equal to r xx of 0, which in this problem is sigma squared into b naught squared plus I will have b1 squared plus b2 squared plus b3 squared under this case of study moving average of order 3. I hope by the end of this lecture you will feel very comfortable to do any problem and also understand the concept of finding mean, variance and autocorrelation function for a moving average process. Thank you.